Alright, in this video I want to talk about just trig functions and right triangles. So the idea is you have a right triangle, and so there's our 90-degree angle there on the bottom right. Not the best right triangle in the world, but I think you get the idea. Suppose we call the angle in the bottom left corner theta, and we'll label the side opposite theta, we'll just call that O. We'll call the long side, the hypotenuse, we'll call that H, and we'll call the adjacent side A. So there's a relationship involving sine of theta, cosine of theta, and tangent of theta that you can read off of this triangle. Sine of theta is going to be defined to be the side opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent of theta is going to be the opposite over the adjacent. From that we can get cosecant of theta, since that's just the flip of sine theta. That'll be hypotenuse over adjacent. Secant of theta, that's the flip of cosine. That'll be, hypotenuse over opposite. Almost didn't catch that. Just looking further. Secant of theta is the flip of cosine. That one will be hypotenuse over adjacent. And then cotangent of theta is going to simply be adjacent over opposite. Okay, so let's do some problems involving this stuff here. So suppose we want to find, let's say tangent of theta, and let's find secant of theta. If we're given the following, suppose we're given that sine of theta equals 3/5, and that theta is between 0 and pi over 2. Alright, so if theta is between 0 and pi over 2, in terms of the circle, that means it's somewhere in the top right quadrant. And if you think about the trig functions, all the trig functions are positive there. So tangent of theta should be a positive number. Secant of theta should also be a positive number. But all I do here is just make a little right triangle. So there's theta. Again, sine of theta is defined to be the opposite over the hypotenuse. So that means the opposite side is 3. The hypotenuse side is 5. And then to figure out the missing side, the adjacent side, remember we can use Pythagorean theorem, and it says if you take the two shorter sides and square those, that has to equal the longer side squared. So 5 squared is 25, 3 squared is 9. If we subtract 25 minus 9, we get 16. So a squared equals 16. If you take the square root, normally you get positive and negative, but obviously the length has to be positive. So the adjacent side is 4. So this is our familiar 3, 4, 5 triangle. So if we want to figure out what tangent of theta is, again, tangent is defined to be the opposite over the adjacent. So tangent of theta will be 3/4. Secant of theta, is defined to be the hypotenuse over the adjacent. So secant of theta will simply be the hypotenuse, 5 over the adjacent, which is 4. And there are your solutions. Okay. Let's do another one similar to this. Suppose we're given that cosine of theta equals, let's say, -1/3. And let's suppose that theta is between pi and 3 pi over 2. So again, pi and 3 pi over 2 is somewhere in the bottom left quadrant. And what I do for these, even though it's a negative, when I make my right triangle, I don't even really think about that. Okay, so here's theta. Again, cosine, we said that that's the adjacent. Cosine's the adjacent over the hypotenuse. So that means the adjacent will be 1, the hypotenuse will be 3, Again, to figure out the missing side, we'll take 1 squared plus the opposite side squared. Oh, that looks like a 0. Oh well, it's supposed to be opposite. Equals 3 squared. So that means the opposite side squared is going to equal 9 minus 1, which is 8. So the opposite side is going to equal simply square root of 8. So the opposite side, I'll put OP down there for opposite. Alright, so again, now the same thing. If we want to just find again tangent of theta, and also if we want to figure out secant of theta from this triangle, we do the same thing as before. So tangent is the opposite over the adjacent, so square root of 8 over 1, and this is where I think about sines. So tangent is the sine divided by cosine, which is the x-coordinate divided by the y-coordinate. Well, both the x-coordinate and the y-coordinate are going to be negative in the bottom left quadrant, so tangent should be positive. Secant of theta, again, we could really just flip the value we have already, but if we didn't think about it that way, if we did hypotenuse, which is 3, over adjacent, which is 1, and again, if you think about secant, that's 1 over cosine. Cosine is the x-coordinate, so on the bottom left quadrant, cosine is negative. Well, 1 over a negative is also a negative, so secant of theta would simply equal negative 3. And again, those would be your solutions. Let's do maybe one more. Suppose we want to figure out sine of 2y, and we're given that secant of y equals 5/4, and suppose that the angle y is between 0 and pi over 2. Okay, so the same thing, we know that our angle is between 0 and pi over 2, so it's in the top right quadrant. Sorry, squeeze it back in there. So secant, if we make our little right triangle, so now my angle, instead of being called theta, is being called y. Secant, again, we said that that was the hypotenuse over the adjacent. So that means the hypotenuse is 5, the adjacent is 4. We could do Pythagorean theorem again to find, in this case, that the other side is 3. Well, to figure out sine of 2y, this is where you have to use your trig identities. There's a trig identity that says sine of 2y is equivalent to 2 sine y cosine y. And now we simply read off our values. Sine, again, being the opposite over the hypotenuse, cosine being the adjacent over the hypotenuse. Well, the opposite over the hypotenuse will be 3/5. The adjacent over the hypotenuse will be 4/5. And you could think about 2 as simply being 2 over 1. We just multiply across the top. 2 times 3 is 6, times 4 is 24. And on the bottom, 25. And that will be our solution. Remember, sine of any quantity has to be something between positive 1 and negative 1, which this certainly is. But if we had gotten a value, if this worked out to be 7/3 or something, you would know that you definitely had made a mistake somewhere along the lines. So there's a little bit of basic trig stuff involving right triangles. If you need to see some other things involving trig, feel free to take a look at my website. I've got quite a few trig videos with more coming, along with a ton of calculus and algebra videos. If you have any questions, feel free to send me an email, and I'll try to address those as soon as possible.